300 longest increasing subsequence from LeetCode. Let's jump to the question. Given an integer array nums, return the length of the longest strictly increasing subsequence. What is a subsequence? A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. So the question is saying an array of integer is given and we should find the longest subsequence and return the length of the longest subsequence. For this example, we can have like 2, 5, 7, 101 here as a substring, and the length of this subsequence is going to be 4. Or we could do also like we could do like 2, 5, 7, 18, and that was right too. So we could have different combination. We don't care about the combination. We care about the length of longest subsequence. In the second example, as you see here, we have 0, 1, and then 2, 3, and the length of the longest subsequence is going to be 4. And the third example, as you see, we don't have any increasing order, so the length of the longest subsequence that we can get is going to be 1 because it's number 7 that we have here. So we can solve this problem using two different approaches. One is dynamic programming, the other one is binary search tree. Let's explore these two and see which one is better. So let's start with dynamic programming. For dynamic programming, what we are going to do, we are going to define an array, and this array is going to have the length equal to the length of the nums that we have, which is the integers that we are going to create subsequences from, and we are going to put 1 as value at each index. And the reason that we are doing that is because at each index we are going to have a subsequence of the element that we have at that index. So this is a subsequence that we have at this index, and at least the longest we are going to have length 1 for each array that we get at each index. So the minimum length that we are going to get is going to be 1, and it's going to be the same for all different cases. And what we are going to do after, we are going to iterate over this array of integers, and we are going to update the value that we have at each index. Let's see how we can do that. So we iterate over this array, but we start from index 1. The reason is at index 0 that we have here, the only subsequence that we can get is going to be the value 10, right? And it has a length 1, right? So it cannot be longer than this, so we don't need to go through that. It's not wrong if we put 0 here, but it's not unnecessary. So what we are going to do, we are going to start from index 1, which is going to be here. At index 1, we are going to compare the value that we have here with the previous values. At index 1, we have only one value before, which is 10, and we compare 9 to 10. And if it is bigger, we go through this if loop. And if not, we just go to the next index. So as you see, 9 is not bigger than 10, so this is not an increasing order, so we go to the next index. So and then we update I to index 2, which is going to be here. Now we check 2 with 9 and 10 to see if it is in increasing order. 2 is smaller than 9, 2 is smaller than 10, so we don't go through this if condition, and we go for this third index that we have here, which is going to be index 3 here, and it's going to be value 5. Now we compare 5 with 2, we compare it with 9, and we compare it with 10. As you see, like 5 is not bigger than 10, 5 is not bigger than 9, but 5 is bigger than 2. And if this condition is valid, we check the second condition, and the second condition is saying if the value that we have at index I, which is index 3, which is this one, the value that we have here, which is 1, is smaller than the value that we have, the Vj is 2 here, plus 1, so this is going to be 2. So if 1 is smaller than 2, what we are going to do, we are going to update the value that we have here to dpj plus 1. So what we are going to do, we are going to update this value. Let me clean here. So we are going to update this value to 2, right? As you see here, we have updated this value to 2. Now we go to the next index. At this index, at index 4, which we have 3 here, we are going to check 3 with this, we are going to check 3 with this, and the next one, and this. So 3 is smaller than 10, so this is not valid. 3 is smaller than 9, so it's not increasing order, but 3 is bigger than 2, so this is an increasing order. What we are going to do, so this condition is valid, right? We are going to say the dpi, which is going to be here, right? We are at this point, this one. If 1 is smaller than, what is the dpj? J is index 2, which is this one. If 1 is smaller than 2, what we are going to do, we are going to update this value here to dpj plus 1, which is going to be 2 here, right? So I think you now know how the process works, and as you see here, now we updated this value as well. And this is how we do it. I will do just one more step so you better grasp the concept. So now we are at this point, which is at index 5. We have 7, and we compare it with every single item that we have here. So we check 7 is smaller than 10, is smaller than 9, but is bigger than 2. And then we check if we need to update that, but as you see, we do not need to update it because we have already updated for 5, and now we check for 5, and as you see here, so we check 7 with 5, which is at index 0, 1, 2, 3. So now what we do, we are saying if at index I, which we have 7 is bigger than j, which j is 3, what we are going to do, we are going to check this condition. The dpi, which we have here, is at index 5, we have 1. If this is smaller than the dpj, which is we are at index 3, right here, 2 plus 1, which is going to be 3. So if 1 is smaller than 3, we are going to update this value to 3, as you see here. And this is how we do it. And we know the time complexity for this because we have 2 for loops, and we iterate over this array, and at each point we iterate over the previous elements. It's going to be a quadratic time complexity, and the space complexity is O(n) because we have this array for storing these values here. So let's go through the dynamic, through the binary solution. In the binary solution, what we are going to do, we are going to create a tree, and in this tree, we are going to store the subsequence, and we keep updating this subsequence as we go through the tree. For this one, we are going to use only 1 for loop. And what we are going to do at the end, we are going to return the length of this tree. This way, we are going to get the subsequence and the length together. So for example, in this question, if it was asking to return the longest subsequence, not just the length, so this solution could help very easily. What we are going to do, we are going to iterate over this array, and at every single index, what we are going to do, we are going to update our tree that we have here. And for doing that, we are using bisect left, and you might say, what is bisect? So let's jump through like this code and see what bisect is. The bisect is a library that we can use to iterate over an array and order this array using a binary tree. So how can we do it? Let's say we define a list, an array, and we iterate over this array of integers, and at each point it's gonna we are going to give the tree and the value that we are getting at that point, and then this index, this bisect, it's gonna tell us where we can where we should insert that value in the tree to keep it in increasing order. As you see, we start from 10. At the beginning the tree is empty, then we're gonna put 10 here, and then we have 9, and it says put 9 at index 0, so we insert 9 here, and then we have 2, we insert 2 here, and then we insert 5 in between. So this bisect one gives us the index that we should insert the value in the tree to keep it in order, in increasing order. So this is a good just explanation about what this function does. And as you see here, now as I explained it, so this bisect left gets the tree and gets the value that we get from the array, and it tells us at what index we should insert this. What we can do here, because we are not going to get all the values and we are not going to order this this array, what we are going to do, we are going to just get the numbers and update this tree with the biggest value that comes after the previous numbers. So let's go through a few examples so you can better understand this. So let's say we iterate over this, we get 10, the number is 10, and the bisect function tells us we should insert this at index 0. So we insert it at index 0, and this is what we have as the first item in the tree. And now we go for the second item, which is 9 here, and it tells us 9 is going to be smaller than 10, and it says it should be inserted at index 0, right? It should be before 10. But what should we do here? The trick for this subsequence is here. If the length of the index, if the index is equal to the length of the tree, we are going to append that value to the tree. Otherwise, we are going to just update that value that we have at that index. So it says we should insert it at index 0, which is going to be before 10, and we don't want that. We are not making a sorted list. What we are going to get, we are going to get subsequence that is in increasing order. So if it says we should insert it at index 0, and we have already something at index 0, what we are going to do, we are not going to insert it. We are going to update the value that we have here. Because we don't use insert here, we use append here, right? And let's go through a few examples so you can better understand. So we update the value that we have because the index that is telling us to insert is equal to the length of the, it's not equal to the length of the tree. So what we are going to do, we are going to just update the value that we have at that index. So let's do another example. So now we are at this point. Now we have number 3, and it says insert it at index 0 because it's smaller than 9. And we know that if the length of the index is smaller than, or it's not equal to the length of the tree, what we are going to do, we are going to just update this value here. So it's gonna be 2. So 3 is 2 now. So 10 has been replaced with 9, 9 has been replaced with 2. Now we go through the fourth example. We have 5 here. So it says insert it at index 1 because it's bigger than 2. So what we can do here, now this is the case that we have here. So the length of the tree that we have is 1 now, and the index that we are going to insert it is going to be 1 as well. So we are going to append it. Now we are going to have 2 and 5. And the same thing will happen. 3 is smaller than 5, so it's gonna replace 5, and it's gonna be 2, 3, 7, and then 5 is going to replace 7, and now it's gonna add 101, and then 18 is going to replace 101, and that's the final result that we are going to get, and it's going to return a length 4 at this example. So the time complexity is going to be n log n, and the space complexity is going to be log n, because we have the 3 here. Thank you.